Okay, welcome again. So, new lecture session that's on ventilated corrugated packaging for posters handling, and that is we try to see the importance of why the structural integrity of the package is quite important. Okay, during the posters handling one. So, okay, this outline coming from the starting from the packaging, and then we link here why we use the corrugated package, and finally check here what may be the best optimized package used for the fresh produce. So particularly as you all coming from the background of food and working some students on the packaging itself, we aware why we want to use the packaging. Sometimes protection, preservation, transportation, handling, even for the display. So number of things what we do with the packaging, and nowadays even what are the things we want in the market, like a raw process something is come with the different types of packaging. So now it's like whatever food material come, we are aligned with the package. We cannot ignore the package now, and this situation is like this one. The packages are number of types, number of materials they are used to handle the package. Maybe it's from the, if you consider whole chain, we have starting from the big boxes, small paneers, even the single fruit packaging also used for some fruits and vegetable. So when we see the packaging, it was quite important and plays a very important role to preservation side of the product, preservation of the side of the product. And when it is look for the packaging, because it extend the shelf life, maintain quality, even appealing for the consumers, is the product we can buy it or not buy it. And at the same time, when we concern about product quality, actually maintaining the produce when we keeping inside the package, when you're transporting, handling, idea is the protection is the one of the important concern here when we talk about the packaging side. Because if the package is not good, actually the product get damaged, indirectly linked with your economical losses, whatever transport, whatever other process you do better way. So when we look for the post harvest value chain from starting from the farm, so packaging is involved everywhere. Okay, package is involved everywhere, because in the farm, when you say, sometimes you take the big baskets, big containers, even the gunny bag for transporting one place to another place. Even in the sophisticated way, when in the pack houses, you sorting the fruits and vegetable and making the small packages as per the requirement from the market. So in the fresh produce industry, different sizes, different shapes packaging we are using. And one thing in the protection, what we say here, one concern here is of the mechanical damage, to protect the product from the damaging. Okay, so during transportation, handling, when we see about the mechanical damage, it's important how the package performs and what's its behavior. Okay, behavior is not only for the human, it's for the package as well. At what condition we are using that package? Are we using the transportation side? What may be the temperature, humidity? That also important here. So ultimately, when we look for the packaging, our idea here to minimize the mechanical damage, okay, and improve the performance. Okay, now the whatever we talk here, the things are good or not, our one thing, one criteria to judge it is the performance, how the it giving the performance. Okay, so even the package is not for packaging also for us the important, what is the performance of packaging during this one. So there may be from the whole chain different kind of packages what we deal with, we can discuss this one. Now if you take about the packaging side, is starting from different types, bags, crate, basket, corrugated one, number of type packaging, and even many more. Is just why I show is limited one, even the glasses and other parts. And when we check for the market, what the packaging common dominant one? In the local market, we can say that they make the local basket from wood, bamboo, or something. But internationally, when we say paper, paper base or plastic base, they are the dominant one. And even in the fresh produce industry, for the fresh produce industry, paper based material or corrugated packaging, which is the still demanding or commonly used. There are some reason for the plastic one for the international market they try to, because their chances are getting more damage of the product. So for local market, we can see here the plastic is commonly used, but for international market, even that percentage is quite higher for the paper based or corrugated packaging. Mostly that's why you say here this was predominantly used for the export market. There are some reasons as well. Plastic become expensive, okay, and for corrugated one there is an opportunity to recycle it after use this one, because plastic they can use for many places, but there is a chances here the cost of transporting and bringing back is not feasible. At the same time, there is an opportunity for the micros. If the product get damaged during transportation, they may be still there. Even your new consignment, it will not work. But only for the local market, you can see it comes. And bamboo basket or wooden, we can see in the local mandis and things, they are quite popular ones. So when we look for the corrugated one, now corrugated packaging, probably I believe you all aware in this case. You are our cartons, box, that's our corrugated package, okay. So it's like a paper based material, and that is the most widely, but as per our requirement we can use it. One thing with this package actually, what we consider, they are light in weight, one thing, but stiff. So even the structure integrity is important for that packages, because we need to keep the fruits and vegetable, and sometimes in the pallets we are arranging up to 8 to 10 layers for the market. So it's supposed to be mechanically or structurally strong, otherwise all your fruits may be got damaged. And it's like a little complicated from engineering side, okay, little complicated. That's what we say here, orthotropic sandwich structure, okay. So what is exactly it means, actually like coming this way, the structure is similar to this one, okay. They have all our cartons, they have liners, two liners, in between they have the fluid. And the challenging one, the mechanical properties for each material is different, your fluids as well as your liners, and as per our requirement we can make that one. And there are even that fluids or liners, they are the different types, A, B, C, D, E category. As per their stiffness, thickness, we can use that one. Even when we looking this one, we may have the double layer or triple layer as per the, when we looking for the more shock absorption of the product. So double layer or triple layer for this one. So that's all the basic one for the corrugated carting, and from this one we can make this one. So why is it popular in the market? Because the weight is low, okay. So when we transporting the product, we consider it may save your money, because you can, your weight side is a low one, and the package we can customize as per our requirement. If you have banana, you have your package, you have apple, you have custard apple, you can make it as per, and it is strong enough to hold the package, easy to print, and even finally after your uses it may go easy to recycle and easy to handle even for the people. And the service and is like a dominant, actually there is a change in that sector, strength of the package, and people are working on that one, how to improve this one. It's a coming period. But the challenge with this package. Actually, you can come in that idea here. Though it's the most dominating in the market, used in the each fruits and vegetable whenever you go for internationally import or export market, even from local. But you may be surprised to know one thing: there is a no guideline from the product side. Okay, product side. If you go in the market, you can see every product have their different packages. Different packages in terms, if you get the opportunity to see in the market, you can see if it's a banana, the package size, how they make. If it's an apple, for the custard, they change. And there is a no standard guideline for the package. Suppose that's supposed to be side for apple, that's supposed to be banana, that's supposed to be another fruits. So what the manufacturer do? They do how they want. Or sometimes maybe the traders or pack house person ask them, okay, we want the packages particularly this size and that size. And though it is more dominant, commonly used for distribution, number of variety. Now you come here again with the environment. When I say the packaging, how they behave in the environment. Now the packaging is for two purposes we're using: transportation, storage. And when the fruits vegetable coming for storage, it's supposed to store at lower temperature. It's supposed to store at lower temperature. That's the when we're looking for long-term storage. And as we mentioned, it's a paper-based material. Paper-based material has the property to absorb moisture. So when it's a lower temperature, we keep at suppose 0 degrees Celsius. Some products 4 degrees Celsius, humidity is more than 90%. It has the property to absorb the moisture. When the paper-based material absorbs the moisture, indirectly it loses its strength. Indirectly loses its strength. Okay. And then another story with this one, not only for this one, we keeping the fruits and vegetable in the boxes. And fruits are vegetable like a human, they respire. Taking oxygen, leaving CO2, heat. If it's accumulated there, then chances to accumulate more there, heat spot, damage, home for microorganism, and whole boxes. So that's another part. So we need cooling, lower temperature cooling, forced air cooling. So we pass the cooling air that is passing through the package. Then what we need to do? We need to make the holes to the package. That's what we call the ventilation, and that is the what the importance of ventilation. And that's why you can see one thing in the market, whatever fruits vegetable in the commercial they using, there is a small holes. Okay, small holes just to escape that respiration heat away from the container and take it out. Even in the transportation side, and this one now the challenge here, once our package hygroscopic nature, when we taking some material from that, strength again going to be down, but we need a cooling. That's a challenge here. We need a cooling. We cannot ignore the cooling if you're looking for long-term storage as well as long-term transportation. So okay, we're coming on that point, how to come sort out this one. Then we have that ability for packaging. We want rapid cooling, so we can see more. Now we get if we want the cooling, rapid cooling, why not we go to maximum vents? But maximum vent means weakening the package. So we aware that one, if we more holes means for ventilation, more air is passing, product get equally effect, but at the same time we are disturbing strength of the package. So how much material? And industry also looking, when they have the holes means they look at less material. That's also one thing. So they need to have the build able to respiration and uniform airflow. That's one thing quite important for whole packages, and that is the purpose. One, we require the mechanical strength. Okay, whenever we talk about the performance of the package, particular corrugated one, what is its mechanical strength and how is this cooling performance? Two criteria always there. Without that one, no use of package for the fresh produce industry. So we required vents, and as I mentioned, there is no rules for the packaging. At the same time, there is no rules for the ventilation. How much percent ventilation is supposed to be there? So there are some studies, they come up to 4 to 20%. But you get that idea here. For plastic, up to 20 is okay, but corrugated, if you go more than 10-11%, the structure try to lose its strength. Okay, and important part, what shape for the vents? It is a circular, circular one, square one. So that also depends actually on what location. So all the factors need to be checked. So they lead to, that's why we mention here one thing here, the package what we need that ventilated one, it's supposed to have adequate ventilation, so that may give us uniform cooling. That's one essential criteria, and another one, without losing its mechanical integrity. That's the two things. So the hole size, shape, location, so that is important here, and that how we can design, that is also we can check here, so it may give us sufficient cooling. So in the package, when we look here, pre-cooling probably now I believe everyone aware this one. What is the pre-cooling? As soon as we harvest the product, we try to remove the field heat, so it will help us to extend the shelf life of the product. So as soon as we do the pre-cooling, so before going to the long-term storage, they try to remove, and then we keep the product for our desirable temperature for the longer period. So at the same time, we protection that corrugated boxes from environmental and physical damage, and handling side whatever damage happening, and so reduced losses are always there, because the packaging is the one concern here to reduce the post-harvest losses, and not only from the like a protection from the condition, but at least the environmental condition also it is helping, because sometimes in the transportation side, weather condition also one thing where we want to protect our product. And sometimes when we say the product, when we're transporting, getting the more damage during the transportation, we have the fluids and layers, so they may adding some more fluids or more layers just to make it product more thicker. So it's like a cushioning material that when we say the adding one fluids rather than one, maybe another one, like it's like working as a cushioning material inside a trap, and working like that air when it's inside the trap, it's like insulating material, okay, in the air. And when we arranging in the pack houses, that all boxes, they like to make sure actually, if you will if you any opportunity to visit any cold house where they keeping long term storage, you may found how the ventilation and the cooling they're done actually. So mostly from the holes, they try to make that holes, and the air may be passed from that one, and so that's why that mechanical properties particularly use here to check this one. And after that, recycle things will be happening. Now when we come here, the structural strength, because why we want the structural strength here, important one part is when we absorbing moisture, it may be losing the strength. Another one, when we are arranging the product in the layers or stacking, the bottom one always feeling the more stress, so need to check that one. When they using that much strength, the box is sufficient to hold, even it will not get damage or buckle. Damage is in even the buckling of that package from the bottom side is directly affect the product quality, whatever keeping inside one. So stacking impact, and during the even the vibration, because sometimes the packages we use the transportation side as well whenever in the market, so it may be moving here and there. And even the similar cooling condition, whenever we look for the import and export market, whatever we have the facility in the cold room, same during the containers. So there is a chances an opportunity to work on that area and how to design the manufacturing. And but now you get one thing clear here, still there is a no guideline, okay, no specific guideline for any organization, just not for the package, not for the ventilation. That's why in the market we can see different type of packages, different types of ventilation for the similar product. Okay, now the when they're making this one, the idea here actually when they're making the packaging, that buckle and buckling and things, they like to see here what area it get damaged easily. Is it near where we have the holes, or the middle parts of the package, or the bottom side, or sometimes we have the holding area where they have the openings, but at the same time that is used to hold the package for the labors. So sometimes the idea here, we can increase the strength of the packaging by adding more material, but at the same time it may go towards the cost side. So even what is the important here to get is a more optimization, and this optimization we can do by different ways, by experimental side as well as by simulation side. So as we consider, that's a environmental side, there are number of studies how that storage condition, storage environment affecting the package life actually. So when we come here, we came the package, now today we have the condition like 20 degrees Celsius where we store, then suddenly we keep the package at 4 degrees Celsius, again bringing from back here. Changing in temperature and humidity also drastically reduce the package strength. Probably you, if you work in the fruits and vegetable, and you can get the idea here, changing the storage condition for fruits and vegetable also link with shelf of the product. Then how much that hygroscopic material, that's a paperboard, absorb the moisture, hot one. Then when we arranging in the package, the boxes have sometimes fatigue, creep, and this indirectly linked, because now we're dealing with the package, but at the same time we need to protect the material what is inside the package, because we not directly bother for the simple package, we are bothering what is inside the package. Okay, so because it's for the protection of the fruits and vegetable. And here one study had to come here, the when the humidity is increasing with the normal condition to up to 90%, they found here within a week the strength of the package of 20% reduction. And sometimes, okay, get the idea here, when in the cold storage sometimes we keep the product more than a month or 2 months or 3 months, even sometimes it goes up to 6 months, 6 months of package. And there are some studies for this one, even with a normal ambient condition. Now you can consider normal condition like a 23 degrees Celsius and 50% RH ambient condition, they found they can keep up to 90 days without disturbing, okay, without disturbing the 40% stack reduction, strength reduction of the package. And the engineering properties on the directional side, when we see the fluid and liners have the different properties, even the x-axis and y-axis, it also have the reduction on this one. So there may be something sometimes come like a liner, sometimes sidewall to protect the package, that's also important here. And then when they're looking for the long term stacking on the pallet one, so they like to make sure that one is supposed to stand up to desired period. So they need to link what is the compression strength of the package even for the given storage condition or transportation condition, and how to improve the performance. But now coming here, two things now what we're dealing here with the package, one is strength and one is cooling performance, strength and cooling performance for the package. And particularly there are number of experimental side, because now you come leave the packaging side and they have number of parameters, number of. So first one, they look at the impact one, actually when dropping with the boxes completely. Now the package have the ECT, that's the edge, the strength of the edge. Okay, another one, the strength of the whole box, like a compression. And then even that may be happening, and that is quite important to understand during compression, drop, impact or vibration. That's a similar how we deal with the product, single product. Now the it may do with some laboratory side testings. Okay, one mostly for impact one, we have the drop testing approach. Drop testing approach, particularly whatever we get the package, they go with the testing. So up to certain height, suppose it is our 1 meter or after 10 stacking, mostly for the export container, from the top if it fall down, what side it get damaged easily, and what's the maximum damage intensity, that is all things. Or during vibration, if you're traveling by the road, sometimes by the ship, or sometimes you have different vehicles, so that also checking here if they we keep the product directly on the, because if you see the arrangement of the fruits in the package, sometimes we fill the package completely, sometimes we make the layers, the movement of, there may be sometimes chances to get the movement of the package, movement of the fruits inside the package. And then the vibration transparency is important. So just to get here, transparency means how much intensity we are providing, actually vibration, and how much absorbed by the package. It's supposed to be minimum, so to reduce the damage. Then for the compression, because that's important, they go for the test like a edge crush test from the edge from the pocket, and using with a different environmental condition. Then for this one, the strength prediction, okay, there are some empirical formulas actually. Okay, that is also one of the research area where they go for the different empirical formulas to just to see the relationship between, okay, for how many days we are keeping, what is the size of that, what is the strength will be we can achieve after certain period. So these all formulas, we have the empirical one, but this empirical formula we start with the, if you consider here for these two formulas in 1952 and 1963, means they starting the research on that one in the that side, but it's just between just to predict the compression strength of the package. That is the one criteria. But nowadays we are coming in the more advanced stage, even using some mathematical approaches or modeling approaches to do that one, because important part now strength, compression strength, how to link with the moisture content of the package, and how to link with even the dynamic environment. Okay. Then the best approach what they come here like a finite element one. Okay, finite element modeling approach that is commonly used now. It's used for the fruits as well, but at the same time with the package. So it may give us the idea how the corrugated package behaving during the giving the dynamic environment. So mostly number of studies they can, and it is coming in this one with we look for the empirical models and things. That finite element is a quite good agreement to check this one. The best part with that finite element with this one, because when in the mass level we need to develop some packages for the industry side, this study is quite helpful to give this one. Now we can see even in the some examples how we can correlate this one. So in the semi-empirical formula there are some issues, because not all environmental factors we can consider, because we sometimes we rely on moisture content of package, temperature, relative humidity, and come with BCD. But now you can see here when we talk about the package performance or structural strength, there are number of parameters increasing stacking strength, box compression strength, edge strength, that is all involved in that one. So in of finite element 1, we have opportunity to use all the factors. So now you can see here this package actually, this is used with the finite element simulation. Now in the first one, what we see here, the box without any holes, no ventilation at all. So the part little bit yellowish one, like the corners. Okay, what it indicates here, this location experience little more stress compared to others, but up to still it's in the range. Then we move to the box actually, where we can have the vents, longitudinal vents, and then we can find here the stress distribution is try to increase. The color of that dark gray blue become little light. Okay, but near the holes we found here the stress is going. Okay, but now once we going for the next level, means changing the again the size and shape of that one, how it will improve. So it will give you the idea, these areas may be the your weaker side of the package. You need to give more attention to that one, or change something, or the maybe change the location of the package with the modeling, because in real world in the package experience it's very difficult, because if you have package, how to find this one buckling happening here or not, and based on that one you may go for the new designing side. So mostly they have the same approach. We have pre-processing, we made a design with the knots, coming with the next stage applying the force. Applying force means, like for example we have the package at the bottom one, and when we have the 10 packages over it, so we able to calculate what is the load that bottom package is experiencing one, and that maybe we can use for utilize for our models. So even we have the opportunity here to play with the geometry, play with the location, and then we can test, develop the package based on that one, and then compare the studies. So even the properties with the package, we are changing the fluids, changing the liners. As we mentioned again, there are number of 5 types of fluids. Okay, you can consider there are, and it changes with the strength to strength, A, B, C, D up to E. Even the fluids and liners, they are changing, and this finite element 1 exactly predict us what may be the air strength, what may be the compression strength, and what may be the issues happening near the areas where we are taking the out from the submergals in the holes. Okay, so we have one study actually, so where we can see the package. Actually we use the corrugated package and using the simulated transport, how to do this one. So here in this study we have 2 different packages with the different sizes and different ventilations, and this package we selected because this package is commonly used for the export market, to transport that apple from South Africa to European market. So they have the different size and the holes, and once we have the simulated transport, we using the different frequency. That frequency, how we get this one, you get the idea here when we transporting the product. Okay, so whatever we study do in the lab, real world we can do in the simulation side. When we have the vehicle or truck, when we transporting by the road, why we get the vibration? Because of due to more frequency. So that frequency we can use for the simulation side for particular distance. Suppose we want to travel 100 km, 200 km, 300 km. Based on that one, duration we can use with the simulation. Then we did here 3 different vibrations applied there for the package, and look here how it is affecting. Now of course what we check here, the bruising and things, so they also look here the bruising here from the yesterday's side, and then we can look for the package transferability. That is important, how much frequency applied here and how much absorbed by the package. And then of course for the product quality parameters like bruise area and bruise volume. Then the transferability what they found here, with the different packages, because the size and location of the vents are quite different, they give us the different ideas about how much vibration they are absorbing for the packaging one. And the absorptions means the transferability is directly linked with the bruise area now, the damaging. So it's a less number for this one, so we can consider here the package and fruits may be less damage inside. And when again, this is again to see here, when we're using that vibration side, that numbers, when we say when we driving in the rough road or higher frequency side, even that trays get completely damaged or broken. So indirectly it may link with the fruits even. If we consider we transporting 200 kilometer, 300 kilometer with a high frequency, high speed, and fruit get expensive, even we can the cushioning. So now here the opportunity is here, we look for the package as well as the cushioning material what we want to use to protect the fruits and vegetable inside the package. So mostly we can found here the cracks, particularly not the top layer, the bottom side one get a crack completely, because the bottom side, that's the place the fruits experience more stress on the boxes. Then another one, there was a study for they use again the two different types of packages, corrugated packages for the banana. Is a study from the Australian market. Now in this one, this type of package we use here to transport banana, like a single piece and double piece package. And then what they do here is a simulation. Now you can consider this the picture of this one. This is the pallet what we saying here. It's like a real world experimentation here. They have the stacking the banana with a number of layers up to 8 to 10, and similar experiment rather than single box, now the whole pallets they are using the vibration. Okay, and the experiment, like, because this one like a trailer, and their idea was that one they transport more than 1,000 kilometer, because it's like a country was, it's like a coast of Australia they make that one, and just to simulate how we are transporting from that 1,000 kilometer that product. Then it's like a once we get this one, and then they go here to check here the properties, like what is the mechanical damage directly, and link with the what is the vibration transferability for the package, how we link that one, if the package is absorbing vibration, and how it links with the damage of the product. And though after this one, now we may come here that one, though with using properly and bottom side rubbing that layer, and these parts is directly our bruise. Okay, what we talk about a bruise, the packaging get higher transferability value, indirectly linked with the product quality what we keeping inside the package. Even and this one visible because 1,000 kilometer, of course it taking that more than 1 day, so after 24 hours is visible completely, and that is linked with your again the physiological changes, increasing transpiration, water loss, and things. And then they call here mechanical damage index, and they coming the idea here, the particularly open package is getting more damage, just to compare with the package, different packages, different designs, because you have that opportunity now. You can design your package and see for the this product, how is suitable, making the single package, multi-package, you want the different ventilation side. Then another one, like where we can see the rather vibration. What about the compression? If you use the compression study for this one, now we have the package we keeping in the common environment, and that's the compression testing machine actually, where we have the package just to check now how when we're applying the force on this one, this load commonly come with the what the whole pallet we can arrange actually, that may be the force supposed to be applied there, and how the package is behaving on that force. And the package, when we're applying the force, now you can see here the middle part where the we have the holes, and here tend to be under buckling. Inside it moves inside, okay, and similar to this side. So we have the experimentals here, and we set up into the finite element here again. Now you can see here the under buckling here in the middle part, and even the damage what we predicted here is similar like the experimental side. Even this part is the weakening part here, where they're looking for the new design of the package to consider the factor here. The middle part maybe need to be strong limit, or otherwise they need to change the location of the vents. Even the top layer, but top layer still is a permissible one. But when you see the in the red side, another one, this package is little buckling, under buckling, still it coming, but compared to another packages has less effect. So when we're talking about advocating about that modeling approach and link with the experimental side, it has the opportunity for the researcher in this area to come with the unique or the design for particular product, considering the all factors to design the package one. Okay, and now we talk about the here the finite element one, but again the cooling performance. Okay, the cooling performance, it's supposed to link with our cooling studies. So when that is also we can do with the simulation side. One is with the finite element, when we say about the mechanical strength and structural strength of the package. Computational fluid dynamics, CFD, that is the another tool we can use to check the cooling performance. So what will it gives us? It will gives us how the, suppose we have the vents here, when the air is passing, cool air is passing, how is moving inside completely stack, whole stack, it is passing completely, or the product getting the restriction. Because when we, I think there was a study one question, if we making the cushioning material, it may be restricting the air flow or not. So by simulation we able to see, okay, whatever the air we are going, is this coming out from the opposite side or not. So because that air is supposed to trap inside, and at the same time each fruits inside the package get uniform cooling. If not that one happening, you consider, okay, if the long term scenario, if your product you are transporting for 2 weeks, 3 weeks, and one product never get a cooling effect, now high respiration linked with the physiological changes and a damaging, even if other products are good but one product not, it may in the 3 week you are damage your whole box. So mostly times for the optimization that things, we need to look to three things in the detailing one. One is your structural, like a finite element, plus computational fluid dynamics, and not to forget one thing, plus that is your quality characteristics of the product. At the end, what we're looking, that's the product what we're keeping here, it maintain the quality throughout the whole journey. So based on this one, we optimize some, and probably those working in the packaging side, even I urge for this one, try to explore this area, because this area still not many research in this particular one. This is a quite a good opportunity, as industries sometimes they want the packaging but come with a more systematic way. Okay, so there are some studies and some papers, if you like to go in the more detail, more about the how to structure design, how to that vents, where to locate, even the finite element, how we are applying for the particularly when design the package, this may become in this way. So what location, up to what the optimized size, where this may give the guideline for this one, or what may be structural integrity, or even how we are implementing finite element for the handling the packaging as well as the fruits combined together. So this about the ventilated packaging, but importantly you get one idea here why we want to vents, because fruits and vegetable like us, they respires. Okay, so we stop with this one here. Okay, thank you. So we expect some queries, questions.
Good afternoon, sir. Sir, which material there is using for that ventilated corrugated paperboard?
It's like our paper based corrugated, like if you see the cartons actually. So it's that same material actually we use.
Okay. Sir, then means you are saying about it will absorb more moisture.
Yes.
So how long we can transport in these paper boards? Like
some studies this goes up to the 90 days in the storage side. Okay, if we not changing, like suppose we keep the package today is 4 degrees Celsius, tomorrow 23 degrees Celsius again, so it will not withstand for longer period. But if we maintain, we keep in the same condition at 0 degrees Celsius, 4 degrees Celsius, it may go up to 90 days, even more than that. And but there is a stacking, we can see the loss up to 50% of the strength. But once we take it out, maybe you cannot utilize the package again.
okay.
But in the if you using for temperature fluctuation, so even the time may be less, it will not go for longer period.
Okay. Sir, it is suitable for our horticultural produce,
Yes.
like
Yes.
fruits and vegetables.
Fruits and the fruits which respires. Okay.
That respires.
Any kind of fruits and vegetable we can do that one.
Okay, sir. Thank you, sir.
Good afternoon, sir. My question is, does this ventilated corrugated packaging affect the labeling or branding?
No, not really.
No?
Because it's like a outer side actually. We're not compromising strength, and the labeling and it's not during the manufacturing process actually. Mostly the labels and designing graphics during manufacturing of the package. Okay. So it will not affect particularly the performance of the package.
Okay. Sir, one more question. Does it affect the structural integrity of the product? If
no,
yes, how?
Particularly if we see here, we are planning to protect the fruits and vegetable inside the package. So integrity of the package, if indirectly it disturb the fruits and vegetable.
Okay. Thank you, sir.
So